This video is on Unit 8, Chapter 16, the unit circle, Lesson number 2, the unit circle, and this is the second video, so part 2 of 2. On the screen right now, I have a reminder that in a unit circle, the radius is 1, and for your sine of theta, it's y over the radius, which in a unit circle, again, is 1, so that's equal to y. Cosine is x over r, and again, because the radius is 1, it becomes x over 1, and you get x for the cosine, and then tangent, of course, is y over x. So those trig ratios are very important for what we do in here, along with what you might see if you take pre-calc. The coordinates of P can be written as the cosine of theta, sine theta. So again, cosine is your x, sine is your y. I would like to quickly go through the unit circle one more time. I'm going to use this one that already has the degree measures on there. So just as a reminder, your 0 degrees is on your x-axis, and then 90 degrees is straight up, 180 degrees is the negative x-axis, 270 is down at the negative y-axis, and then of course you come back to 360. Each quadrant is broken down into a multiple of 30 and 45. And then, of course, you've got your 60. So to put the radian measures in, of course, 0 degrees is 0 radians. And then our multiples of 30. I'll start with multiples of 30. So 30 is 1/6 pi, 2/6. Let me reduce that. 2/6 pi becomes the 1/3. 3/6 for 90 is 1/2. 4/6 reduces to 2/3. 5/6, and then 6/6. So that completes the top half of the unit circle, and we'll keep going. 7/6 for 210. 240 is going to be our 8/6, which is 4/3. 270 is 9/6, which would be 3/2. And then 330 would be 10/6. 330 is going to be 11/6. And then 360 is your 2 pi. So that takes care of all of our multiples of 30, and then we can go in and add our 45. 45 is 1/4 pi. 90 would be 2/4. 135 is 3/4. And then 180 is our 4/4. 225 is 5/4 pi. 270 is 6/4 pi. 315 is 7/4 pi. And then, of course, 8/4 pi would be our 360. So that gets the radian measures in there. And then we'll add our ordered pairs. So I'll add the ones that are on each axis. So at 0 or 360, you have 1, 0. At 90, we got 0, 1. At 180, we got -1, 0. And at 270, 0, -1. All right. So those are actually called, if you remember from your notes in the previous video, those are our quadrantal angles. And now I'm going to add in the rest. Using my left-hand trick, again, follow along with me. So looking at your left hand, looking at the palm of your left hand, you're going to do the 30 degrees. So let's put down our ring finger. And you've got 3 fingers on the left, so that's going to be the square root of 3 over 2, and then our 1/2. So that gets that's our 30 degree. Now think about all those reference angles. So 30 degrees, 150, 210, and 330 all have a reference angle measure of 30 degrees. So all of those ordered pairs are the same. So for the 150, we just have to make sure that we use the negative for the x, because in your second quadrant, the x is negative and the y is positive. In quadrant 1, both are positive. In quadrant 3, they're both negative. So for 210 degrees, I have negative radical 3 over 2 and negative 1/2. And for 330, we have the x is positive and the y is negative. So positive radical 3 over 2 and negative 1/2. All right, so going back to your left-hand trick, put your middle finger down for 45 degrees, and you have 2 fingers on the left, so square root of 2 over 2, and 2 fingers on the right. And then we'll fill in the rest. The 135, so 135, 225, and 315. Those 4 angles have a 45-degree reference angle. So we can fill those in to match. Again, in the second quadrant, the x is negative, the y is positive. In the third quadrant, they're both negative. And then in quadrant 4, x is positive, y is negative. And last but not least, put your index finger down or your pointer finger for 60 degrees. In your 60-degree angle, here's a 60-degree reference angle. That's going to include the 120, the 240, and the 300. So I have 1 finger on the left and 3 fingers on the right. And then for 120, we just have to make the x negative. And in quadrant 3, for the 240 degree, they're both negative. And then again in quadrant 4, the x is positive and the y is negative. So there is our unit circle. Looking at the bottom of this page, you have this page in your notes, and we're going to try to fill in the bottom of this. So the trig values, remember that the sine of theta is the y value. So in every single one of these, if you have your unit circle, in every single one of those, we know that the sine of that measure is equal to the y coordinate in the ordered pair. So the significance of the unit circle is this. If I were looking for, say, the sine of 300, so you go to the 300 degrees, sine is y, so it's equal to negative radical 3 over 2. Now that's the quick and easy way of explaining it, and I'll explain more in just a little bit. But cosine is the x coordinate, and tangent is y over x. So you have to know those. And then summary of our signs in our quadrants. So think about quadrant 1. In quadrant 1, everything is positive. Your x is positive, your y is positive. So in the first quadrant, everything is going to be positive. The sine is positive, the cosine is positive, and when we divide those two, it's still going to be positive. In the second quadrant, we know that the x-coordinate is negative. So if the x-coordinate, focus right here, if the x-coordinate is negative, then that means our cosine is negative. But sine is going to be positive. And then think about tangent. Tangent, we have to divide the two. So when we take a negative and we divide by positive, or positive divided by negative, it's still going to be negative. In the third quadrant, both the x and the y are negative. So sine is y, it's negative in the third quadrant. Cosine is the x, and if x is negative in the third quadrant, so is the cosine. But tangent in this instance is going to be positive because a negative divided by a negative is positive. In quadrant 4, your x is positive. So since x is positive, cosine is positive. My y is negative, so sine is negative. And once again, dividing those two, the tangent is going to be negative. So let's go back in our notes to this page. Signs of trig functions. Which trig functions are positive in quadrant 1? Well, we just saw in quadrant 1, everything is positive. So I'm going to write all. When in quadrant 2, think about quadrant 2, the x value is negative. The y value, or the y coordinate, is positive. So if the x is negative and x is the cosine, then sine is going to be positive because the y is positive, so sine is positive. But tangent is not. Tangent is not positive because we got a positive and a negative. When we divide, we get negative. In quadrant 3, remember that your x is negative and your y is negative. So the cosine is negative, the sine is negative. But in this one, tangent is going to be positive because we divide a negative by a negative. And then lastly, in quadrant 4, the x is positive and the y is negative. So the sine is your y value. So for quadrant 4, the answer to this one's going to be cosine. Cosine is positive because your x is your cosine. I think I said that backwards just a second ago. X is your cosine, y is your sine, and x is positive in quadrant 4. So there's in the bold black here, it says, remember the phrase, all students take calculus. And that just kind of helps you remember. In quadrant 1, all of them are positive. And in quadrant 2, your sine is positive. Quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So let's move through some of these questions here. If tangent of theta, I'm looking at number 1. If tangent of theta is greater than 0, which quadrant or quadrants could the terminal side of theta lie? So we're looking for where is tangent positive because it says greater than 0. So where is tangent positive? Well, tangent is positive in quadrant 1 and quadrant 3. Let's look at number 2. If the secant of theta is less than 0, which quadrant or quadrants could the terminal side of theta lie? So this is asking us about secant being less than 0. So where is secant negative? Well, secant goes with cosine. So where is cosine negative? Well, we know cosine is positive in quadrant 1 and in quadrant 4. So it's going to be negative in quadrant 2 or quadrant 3. Right? So for that, you just kind of have to read the description and figure out which quadrant or quadrants could make that statement true. All right, what I want to do now is using reference angles to find trig values and thinking about our unit circle and our left-hand trick. So step number 1 says find the measure of the reference angle. Step number 2, identify the trig function for the reference angle, and then adjust the sign if needed. So the directions here tell us to give the exact value for each trig function. And remember that your sine is your y, cosine is the x, and tangent is y over x. So looking at question number 5, it asks me to find the sine of 150. I'm going to show you a couple of different things here. So if you have your unit circle drawn out, which we just did, but if you have it drawn out, it is as simple as finding the 150. Let me jump to this screen. Finding 150. I'm going to highlight the 150, which is here, right? And we know that sine is the y-coordinate. The y-coordinate there is 1/2. So the answer to question number 5 is 1/2. Now, what if we don't have the unit circle drawn out. The left-hand trick is what I use. And if you look at step number 1, it's kind of important if you're just using your left-hand trick. Find the measure of the reference angle. And I'm going to go one step further. Also identify the quadrant. So tangent of number 6 says tangent. Actually, let me not do number 6. Let me do number, well, I'm going to do number 6. Tangent of 300. So 300 is going to be in quadrant 4, and it has a reference angle of 60 degrees. Now, the reason why the quadrant is significant is because in quadrant 4, the x is positive and the y is negative, right? So the x is positive and the y is negative. Now, since my reference angle is 60 degrees, I want you to look at the palm side of your left hand and put down your index finger. The ordered pair is 1/2 and the square root of 3 over 2. Now, tangent is y divided by x. So we're going to take that y value and we're going to divide by the x. So we're going to multiply by the reciprocal of the x. And I just kept it the same. I need to flip it. And then reduce. The 2's will cancel. And the answer here is the square root of 3. So let's do that. Let's do another one. Number 7 says the cosine of 225. Now, cosine of 225 is has a reference angle of 45 degrees. And I know this is in quadrant 3. And again, the significance of this is that both the x and the y are negative in quadrant 3. Now, cosine is the x-coordinate of that angle. So think about, if you look at your left hand, 45 degrees is your middle finger. The x and the y are negative radical 2 over 2. And it's asking me for the cosine, and cosine is the x. So the answer here is negative radical 2 over 2. So to be perfectly honest here, and totally upfront, I don't really use the unit circle a lot here to evaluate these trig ratios, but you certainly can if you've got it written out. Let's look at cotangent. Number 8 is the cotangent of 315. So 315 degrees is going to be in quadrant 4. And my reference angle here is another 45 degrees. And in quadrant 4, the x is positive and the y is negative. So the ordered pair is, if you look at your left hand, put your middle finger down, it's a positive radical 2 over 2 and a negative radical 2 over 2. Now, tangent is y divided by x. So cotangent is x divided by y. So we're going to take the x, which is a positive radical 2 over 2. We're going to divide by the y, which means we're going to multiply by the reciprocal, which is going to give us negative 1. All right, let's jump down to some of these that have the radian measures. So cosine of 11 pi over 6. Here's my little trick. If the denominator is a 6, then I know the reference angle is 30. Reference angle is 30. Now, where is 11 pi over 6? What quadrant is it in? Well, 11 pi over 6 is almost 12 over 6, which would be 2 pi. So we're in quadrant 4. And in quadrant 4, the x is positive and the y is negative. 30 degrees, so put your ring finger down. The ordered pair is a positive radical 3 over 2, negative 1/2. And then it asks us for the cosine. The cosine is the x coordinate, so the answer here is radical 3 over 2. And again, I didn't need the unit circle. Now, I totally could use it. Let's look at number 13, for example. Number 13 says the sine of 4 pi over 3. So let's go to our unit circle and find 4 pi over 3. And I see it. It is the same as 240 degrees. And in that problem, we were asked to find the sine, right? So I'm working on number 13. The sine of 4 pi over 3. So the sine is the same thing as the y-coordinate. And the y-coordinate there is negative radical 3 over 2. So negative radical 3 over 2 is my answer. So I've shown you two different ways to do this. One using the unit circle and one just using your left-hand trick. I do want to show you number 12, cosecant of 7 pi over 4. So 7 pi over 4, I'm going to show you using the unit circle again. We need to find 7 pi over 4. 7 pi over 4 is here. Okay. I'm going to write the ordered pair on the other page. So radical 2 over 2, negative radical 2 over 2 is my ordered pair. Now for cosecant, cosecant is the inverse of sine, and sine is the y. So take that y coordinate and just flip it upside down, because that's what happens when we go from sine to cosecant. And then we need to fix that. I have negative 2 radical 2 over 2, which the 2's are going to cancel, leaving us a final answer of negative radical 2. All right, so there's your notes on how to use the unit circle. So chapter 16, lesson number 2, video number 2.